Okay, guys, we are on our last video, woohoo, of the year. So we are on lesson 31. We're dealing more with complex numbers, but we're dealing with the operations of those of those complex numbers. So when you're adding complex numbers, you're going to add the reals together. You're going to add the imaginaries together. So here we go. So 3 plus 7 gets me 10. 4i minus 20i gets me negative 16i. Subtraction. We do the same thing. We have the reals that are going to get added together. We have the imaginaries are subtracted. So 3 minus 7. So that would get negative 4. 4i minus negative 20. That's going to get us plus 24i. And if some of you are having a tough time with that, because this negative would be distributed. Okay, so now we have multiplication. But multiplication is going to work the same way that we did with multiplication earlier with polynomials. Again, do you notice here, boys and girls, these are conjugates of each other. The only difference is the sign in the middle. These are conjugates. And the great thing about conjugates is what you're going to see that happens right now. So, I take 1 and I multiply it by 1. I get 1. Take 1 by negative 2i. I take 2i by 1. And I get 2i, minus, that's just not going to work, minus 4i squared. Now, do you realize that this is the difference of two squares? So this whole middle section goes bye-bye. 1 minus 4, but do you remember that I squared is equal to negative 1? So I have times negative 1. So we get 5. Ooh, so the cool thing about this is when I multiply by the conjugate, I get a real number. When I multiply a number by its conjugate, I get a real number. I no longer have a complex number. So here we have, on number 6, it wants us to verify that these two are the solutions to this. So let's find it out. So we have x squared plus 2x. Why am I rewriting this? My a value is 1, b value is 2, c value is 5. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's plug it in. Negative 2 plus or minus the square root of 4 minus 4 times 1 times 5. All over 2 times 1. So I have negative 2 plus or minus the square root of 4 minus 20 over 2. So I get x equals negative 2 plus or minus the square root of negative 16 over 2. I have to bring this up over here. So x equals negative 2 plus or minus 4i over 2. Remember, I split it up. Negative 2 over 2 plus or minus 4i over 2. So I get negative 1 plus or minus 2i. And amazingly, That's what we have right there. Okay. So let's look at this. We need to find out our pattern for this. So difference of two squares. Remember that if I have this times this, that is just going to be the first one squared minus the second one squared. Okay, so here we go. X squared minus I squared. But I squared, sorry, I don't want to write it like that. Remember that I squared equals negative 1. So it's x squared minus negative 1. So now I've got the plus 1. And the reason that it's plus 1 is because we're dealing with imaginary numbers. So let's look at this one. X squared minus 25i squared. So that gets me x squared plus 25. Okay, I want to do another one of those off to the side right here. Big, different color. Let's see. X minus 6i, x plus 6i. Now, if you notice the pattern right here, the first and the second are squared, and I have a plus sign in the middle. The first and the second are squared, and I have a plus sign in the middle. So I have x squared, I have a plus sign. What's 6 squared? 36. Let's do another one. I have x minus 12i, x plus 12i. So I have the first one squared plus the coefficient squared. Let's try another one. We'll do this color. We're going to do 3x minus 4, 3x plus 4. Ooh, I forgot the i's. Sorry. So this gets me 9x squared plus 16. Okay, so this one is a little different, and I'm sure you're looking at this and you're going, what? But it's not that bad. I'm going to multiply or distribute that negative through, and I'm going to write it like this. So, hopefully you notice that this first part and this first part are exactly the same. Then we have a minus and a plus and with an I. So we're going to rewrite this. We're going to rewrite it as x minus 2 in parentheses minus I, x minus 2 in parentheses plus I. We're going to pretend like that is the same thing as up here having this and this. We're just going to square it. Not a big deal. We're going to take the first term, which is that, and we're going to square it. Then we have negative I squared, because it's the difference of two squares. So x squared minus 4x plus 4 plus 1. So x squared minus 4x plus 5. I know you have questions. We're going to do it again in a second. So remember on the ones we just did, if I had x plus 4i and x minus 4i, that is just going to be x squared plus 16. So we're going to look at this. What times itself gets x squared? X. One of them is going to be plus, one of them is going to be minus. and this would be 3i and 3i. Before we do number 9, we're going to do another one. So if I add x squared plus 25, right? Okay. So again, because it has plus instead of minus for the difference of squares, we get 5i, 5i. Okay. Now, this one's a little bit different, but not really. We still have our x and a plus and a minus. The thing is we can't take the square root of 5. So we have to have the square root of 5 with an I, like so. Okay. Now, this is where our conjugates come into play. What we're trying to do is now we're trying to write an equation. And right now, do you notice how these are conjugates of each other? I want to use the lighter blue. Okay, so these are roots. So that means that if we're using the zero product property, x equals -2, x equals 3, x equals -4i, and x equals 4i. Why they don't have x equals in the front up here, I don't know, but they just listed the roots. So if I was to move the numbers over, I would get x plus 2 equals 0, x minus 3 equals 0. Oops, I didn't mean to do that. X plus 4i equals 0, and x minus 4i equals 0. So all it's asking you to do is have everything multiplied by each other, and you have it equal to 0. So I have x plus 2, x minus 3, x plus 4i, and x minus 4i. Now just think about it. If I started with this step here, and I said to find the zeros, wouldn't you do these steps up here? So we're just going backwards. That's all we've done. Now it wants you to multiply it out. So if I was to multiply these two, I would get x squared minus x minus 6. We've just done this over and over again. We square the first one, we get a plus sign, and we get 16. Then I multiply that out. So x squared times x squared, x to the 4th. X squared times 16, 16x squared. Negative x times x squared gets negative x to the 3rd. Negative x times 16 is negative 16x. Negative 6 times x squared would be negative 6x squared. And negative 6 times 16 gets negative 96. Oops, that was weird. Okay, got to get rid of both of those. 96. Combine like terms. Put it in descending order. That should be a 4, not a 2. Put it in descending order. And I get plus 10x squared minus 16x minus 96 equals 0. And if I really want to make it into a proper equation, I could have it equals y. Okay. So this is the one that's weird. So x equals 3 plus I, x equals 3 minus I. So I subtract those over, I get x minus 3 minus I equals 0. X minus 3 plus I equals 0. And again, we want to multiply them So we get x minus 3 minus I, x minus 3 plus I. This first part and this first part are exactly the same. So I'm going to write it. X minus 3 in a set of parentheses minus I. Again, x minus 3 in a set of parentheses plus I. So if I take this whole thing and I multiply it by this whole thing, I'm going to get x minus 3 all squared. Then I take the negative I times the positive I, and I would get negative I squared equals 0. So I get x squared minus 6x plus 9 plus 1 equals 0. So x squared plus 6, why did I put plus? I don't know. Minus 6x plus 10 equals y. And I now have an equation. Okay, so now we're going to do our last lesson in algebra. And this lesson is lesson 32. And it's dividing. If you notice, we did multiplying, we did adding and subtracting, but we didn't do any dividing at that point. So we're going to do dividing. And I've told you a couple of times now about the conjugate. Okay? These are conjugates of each other. So, all it does is it takes the opposite of the imaginary part. So on this first one, this is the imaginary part. So I'm going to take the opposite. So 2 minus 3i. That's it. This one, the opposite of the imaginary part, plus 4i. I want you to do C, D, E, and F on your own. This is what you should have gotten. The opposite of a plus 5i is a minus 5i. The opposite of a 3i is a negative 3i. The opposite of a negative 7, oh, it doesn't have an imaginary. So you leave it exactly the same. And F, negative 5i, the opposite of that would be 5i. Okay, next one. We need to graph this. So in order to graph it, this right here is the real number. So this is the real axis, this is the imaginary. Okay? So 3, so I'm going to go over to 3, and it says I'm going to go up 4i. So that's up there. So then I'm going to draw a point. But it's asking for its conjugate. So this is letter A, but it's asking for its conjugate. So it wants 3 minus 4i. So that's going to come down here. I don't know why it's funny. So that's my conjugate. I don't know. That's not how you label it, but I just wanted to label it a different thing. So negative 2, negative I. So I go over to negative 2, and I go down to negative I, and I make a point. Again, I don't need these lines. It's just for effect. And its conjugate would be 2 plus I. So that means it would be up here. So this is letter B, this is B, and its conjugate. 7. 7 is just a real number. So I come over here to 7, and I plot that point. It does not have a conjugate. Then last but certainly not least, it does not have a real number. So I just go up to 4i, I plot a point, and then I go down to negative 4i, and I plot a point. Do you notice that they don't have little eyes on these? It's because you can't really do that in the programs that we have, so they just leave it off. Okay, so here we go. Division. You have to be able to do the conjugate to be able to do this. So we're going to be working with this problem right here, and it's different than any of the stuff that you've done so far. So it says on number 6, to divide complex numbers, we want to make the denominator a real number. We need to multiply the denominator by a complex number that makes it real. And if we remember, before when we multiplied conjugates together, we got a real number. So we're going to multiply the denominator by its conjugate. So let's see. I take 2 plus 5i. That's the right one, right? Yep. And I multiply it by its conjugate, 2 minus 5i. So I get 4, and I get minus 25i squared. So 4 plus 25, so 29. That's a real number. That's what I wanted. So now the goal is to rewrite the expression as an equivalent expression with a denominator that is a real number. So we just did that. We know that we must multiply the denominator by its conjugate. Okay, what about the numerator? Well, I'm not going to write this part down, guys. Guys, if I multiply something by the denominator, I also have to do that in the numerator. We've been doing that with fractions for years now, like when we find the common denominator. So if I multiply the denominator by the conjugate, I need to multiply the numerator also by that conjugate. So let's see, right here. I'm going to multiply numerator and denominator, because isn't this the same thing as multiplying by 1? So if I multiply the numerator, I'm going to get 4 minus 10i minus 12i plus 30i squared. Didn't we already multiply the denominator? So then it got 29. Awesome. So now I have 4 minus 22i minus 30 all over 29. I have to have my real numbers first. So negative 26 minus 22i all over 29. So we're going to do the same thing to number 9. Okay, I need the conjugate of the denominator. That's the first thing. So that's going to be 2 plus 7i. 2 plus 7i. Okay, go ahead and multiply that. I should get 6 plus 21i plus 4i plus 14i squared. This should be, oops, I forgot the negative. Ooh, that's not good. How many people caught my error and did it correctly? That's my fault. So this should be negative 6, and this should be negative 4i. Okay, so then I would have negative 2 squared minus 49i squared. Negative 6 plus 17i minus 14 over 4 plus 49. So that'll get me negative 20 plus 17i over 53. Okay, I want you to try B all by yourself. Okay, so I would have multiplied by 3 plus I, 3 plus I, 9 plus 3i on top, And on bottom, I would get 9 plus 1. So 9 plus 3i all over 10. Okay, that's your last lesson of 8th grade, if you're in 8th grade, of algebra.